Business Intelligence Lecture 2. Today we will learn about data warehousing and ETL. Introduction to data warehousing. Data warehouse design and implementation. Extract, transform, load, ETL processes. Introduction to data warehousing. Data warehousing is a process of collecting, storing, and managing data from various sources to provide a single, comprehensive view of an organization's data. The goal of data warehousing is to facilitate reporting, analysis, and decision-making by providing a central repository of data that is optimized for query and analysis. A data warehouse is a large, centralized repository of data that is specifically designed for reporting and analysis. Data warehouses are typically organized by subject area, such as sales, marketing, or finance, and contain historical data that is aggregated and transformed for analysis. Data warehouses are optimized for query performance and are designed to support complex queries that may involve joining multiple tables or performing advanced analytics. The process of building a data warehouse typically involves several steps, including 1. Data modeling. This involves designing a schema that organizes the data into tables and defines the relationships between them. The schema is typically designed to optimize query performance and support reporting and analysis. 2. ETL, extract, transform, and load ETL tools are used to extract data from various sources, transform it into a standardized format, and load it into the data warehouse. ETL tools can also be used to clean and validate the data to ensure its quality and integrity. 3. Data management. Once the data is loaded into the data warehouse, it must be managed to ensure its accuracy, completeness, and consistency. This can involve data profiling, data cleansing, and data quality checks. 4. Reporting and analysis. Once the data is in the data warehouse, it can be used for reporting and analysis. Reporting tools can be used to generate predefined reports, while analytical tools can be used to perform ad hoc analysis and create custom reports. Data warehousing has many benefits for organizations, including 1. Improved decision-making by providing a single, comprehensive view of an organization's data. Data warehousing enables organizations to make better informed decisions. 2. Faster access to information. Data warehousing is optimized for query performance, which means that users can access the data they need quickly and easily. 3. Better data quality. Data warehousing involves data cleansing and validation, which helps to improve the quality of the data and reduce errors. 4. Improved operational efficiency. Data warehousing can help organizations to streamline their operations and improve their efficiency by providing a centralized repository of data. Data warehouse design and implementation. Designing and implementing a data warehouse involves several steps, including 1. Define business requirements. The first step in data warehouse design is to define the business requirements. This involves understanding the organization's data needs, business goals, and objectives. 2. Choose a data warehouse architecture. The next step is to choose a data warehouse architecture. There are several different architectures to choose from, including a Inman architecture. This architecture focuses on building a centralized data warehouse that integrates data from all sources. B. Kimball architecture. This architecture focuses on building a data warehouse that is optimized for query performance and supports dimensional modeling. C. Hybrid architecture. This architecture combines elements of both the Inman and Kimball architectures. 3. Design the data warehouse schema. The next step is to design the data warehouse schema. This involves designing the tables, columns, and relationships between the data. 4. Choose ETL tools. Extract, transform, and load ETL tools are used to extract data from various sources, transform it into a standardized format, and load it into the data warehouse. There, are several ETL tools to choose from, including open source tools like Talent and commercial tools like Informatico. 5. Implement the data warehouse. The next step is to implement the data warehouse. This involves setting up the database, loading the data, and configuring the ETL process. 6. Test the data warehouse. Once the data warehouse is implemented, it must be tested to ensure that it is working correctly. This involves testing the ETL process, validating the data, and testing the queries and reports. 7. Deploy the data warehouse. The final step is to deploy the data warehouse. This involves making the data warehouse available to users and integrating it with other applications and systems. When designing and implementing a data warehouse, it is important to consider factors such as scalability, performance, and security. Data warehouses must be able to handle large volumes of data and support complex queries, while also ensuring that the data is secure and protected from unauthorized access or attacks. Extract, transform, load ETL processes. Extract, transform, and load ETL processes are a critical component of data warehousing and business intelligence. ETL is a process of extracting data from various sources, transforming it into a standardized format, and loading it into a target system, such as a data warehouse or a data mart. The ETL process can be broken down into 3 stages. 1. Extraction. In this stage, data is extracted from various sources, such as databases, spreadsheets, or flat files. The data is then transferred to a staging area, where it is temporarily stored before being transformed and loaded into the target system. 2. Transformation. In this stage, the data is transformed into a standardized format that is suitable for analysis and reporting. This can involve a variety of transformations, such as data cleansing, data validation, data enrichment, and data integration. The goal of the transformation stage is to ensure that the data is accurate, consistent, and complete. 3. Loading. In this stage, the transformed data is loaded into the target system, such as a data warehouse or a data mart. The loading process can involve various techniques, such as bulk loading, incremental loading, or real-time loading. The ETL process is a complex and iterative process that requires careful planning, design, and execution. Some of the key considerations when designing and implementing ETL processes include: 1. Data quality. The quality of the data is critical to the success of the ETL process. Data quality issues can arise from various sources, such as data entry errors, data duplication, or data inconsistency. It is important to implement data quality checks and data cleansing techniques to ensure that the data is accurate and reliable. 2. Performance. The performance of the ETL process can have a significant impact on the overall performance of the data warehouse or data mart. It is important to optimize ETL process for performance by using techniques such as parallel processing, data partitioning, or indexing. 3. Scalability. As the volume of data grows, the ETL process must be able to scale to handle the increased data volume. It is important to design the ETL process with scalability in mind by using techniques such as distributed processing, clustering, or cloud-based architectures. For security, the ETL process must be designed with security in mind to ensure that the data is protected from unauthorized access or attacks. This can involve techniques such as data encryption, user authentication, and access control. Thanks for watching. Wait for more informative video.